So hi, this will be our demonstration for the course project of CS 536. And our title is ChatGPT-on-phone Voice2Text, which is our name for the app. So here is an outline for our presentation. It is roughly divided into three parts. The first part is task introduction, then core techniques, and then we will present a video demo. So in short, we develop an Android app which can take voice as input and transform the voice to text. That's the first step. Then the text is sent to GPT model and LLM model as well, and we obtain the response from the OpenAI server or our local server. Finally, the response is transformed back into speech that can be played by the user. So let's get started. This is the task introduction. We develop a mobile app that works with LLM to build a chatbot. The app uses human speech as the input, like left bottom button. You can see there is a microphone icon so that you can speak, and this app will transform your speech into a text input. And then you can press the send button and send the message to either GPT or LLM server, then it will return the text. So for example, we send a hello and it returns, hello, it's nice to meet you. There is something I can help you, or would you like to chat? These apps use text and speech as output, so you can see the text on the screen. Also, you can press the speak button so that it will be transformed into speech. And the core code or the main or the core function of our app is to communicate with large language models. So here we demonstrate how to communicate with GPT. You can see here that we run a curl command. And so in this curl command, we can see the URL and the required fields that we need to fill. For example, the content type, which is JSON, and the authorization, which contains my key. And actually, you need to update your keys in real time so that it won't be disabled by the OpenAI. As for the prompt, it's included in the messages, and the role is user. The content is, for example, what is the capital of France? Then, as shown below, this command is the output for the curl command. You can see that the return content is included in the choices and the messages and the content. Say the capital of France is Paris. Actually, this back and forth interaction is very quick. It usually took less than 1 second. And the other parameters include model and temperature. In this final project, we are using GPT 3.5 Turbo for our final project. And the return content, say the capital of France is Paris, is then processed by our Android app and displayed on the screen as depicted before, right? So as for our lab project, we think, okay, so when I send a message to OpenAI and it returns from the OpenAI, it took so long. What if I set up a local server, say like a Llama, and try to directly communicate with my local server? So a Llama model is set up on my lab server, and it's listening to a port, and we are sending message to that port. And you can see here, this is the correct command to send the request. The URL is changed to the URL that can forward the message to the server port. And you can see the messages content is very similar to the OpenAI API. What is the capital of France? And the return text is kind of collapsed, but we can still see that the capital of France is Paris. Then it introduces some basic information about Paris. That Paris is located somewhere and what is famous for. So let me give you a few more details about the Llama model that is deployed on the server. It is using LLM CPP Python package, and the model is downloaded from the Hugging Face, which is a common place to access the models. And you can notice that the URL link here is very strange. It's actually using ngrok because the server node is not publicly accessible. Therefore, we need a tunneling or a forwarding mechanism to access the node port, right? And we can see that either the request field and the response fields is very different from GPT's. So we need to modify our Android code accordingly so that it can properly communicate with the lab server. And since it's deployed on the local server, there's no field as authorization, right? Because it is my server. I don't need a key to authorize that I'm the user, okay? So there are no additional parameters such as model and temperature. Okay, so these two slides basically explains how we communicate with the large language models. This one, like in the slide shown here, is the way to communicate with OpenAI, and this one shows here is how to communicate with my local server that has Llama deployed on it. And here are a bit more details about the ngrok for Llama, because we can see that here is HTTP localhost 8000, which means that the Llama server is listening at localhost 8000. And this is not accessible by the public internet. So we need to forward in the messages from an outside URL, which is here. It's generated by the ngrok. And this can affect the network latency. We can see that the latency here is 22 microseconds. But it is what we have to do because the GPU node is not publicly accessible for security reasons. And what we can notice here is that the request is sent as post and to this address, and the response is 200 OK, which means the request is handled and the response is sent as 200 OK. If you send something that is not valid or not proper, it will return like 404 not found or something like that, which is of course aligned with the course materials in CS556. And we noticed that we changed the new design to Llama server because we think it might be faster than the OpenAI server. And we make sure that the Llama server is running on GPUs instead of CPUs for inference. So displayed here are the outputs for the Llama server. We can see that the utilization of the GPU is not zeros. It is fully utilizing the 4 GPU cards here for inference. And the execution time is recorded here. You can see like it takes something like 3 seconds, 12 seconds, like that. The performance, even on GPU, is disastrous. I would say disastrous compared with the server at OpenAI, because they have like thousands or hundreds of A100s or H100s. So it is true that the network communication latency is not the bottleneck for our lab's LLM serving task. So we want to further investigate, is it true for the GPT serving task? Because we noticed that GPT is very fast when doing the communication. So this is the performance comparison between the GPT server and the Llama server. The conclusion is like, we cannot safely say that for much faster GPT, the network communication is not the bottleneck. It means that for GPT 3.5, it is possible that the network latency is the bottleneck, because we can see here when we run the curve command, the total time is like hundreds of microseconds. But as for the Llama server, the total time is like tens of seconds. I test both servers with 10 like identical questions. We can see here that the total time and the network processing time are at least at the same order, about like hundreds or tens of microseconds. But on the llama side, you can see that the response is much slower. It took tens of seconds, while the network only takes, tens of microseconds. So that's a huge difference. In demo, we think that llama is faster because we can see later in demo videos that when I'm using llama, it's popping out the response instantaneously. But in the terminal test, the GPT is the winner. We can dive deeper into the reason, but that's what we get from the experiments. It's like in terminals, GPT is faster, but in llama, I mean, in the app demonstration, llama is much faster. Okay, so we then try to ping these two address to see if the network latency is comparable, and we are frustrated to find out that the lab server is beaten in so many ways. It's like it's slower in inference, it is slower in the network latency, but strangely, as I mentioned before, it is just faster when we try to demo it on the phone. And I will let my collaborator Ziling to introduce the voice-to-text function and the text-to-speech function that we use in this app.
Hi, I'm Zilin. I will introduce the technique used to translate the voice to text. We use the recognizer intent and the speech recognizer APIs in the Android Studio to realize the voice to text function in our app. And this function can be integrated for some voice-based commands, and we use it to translate our human voice to the text and as the query sent to the GPT model. And I show some core code here. We first create the intent, and then we set the model for the human speech translation. The recognized speech will be translated to the text in English, and the user can also modify the translated text in our app. And the second technology used for the communication is the text-to-voice. We use text-to-speech class in Android Studio to realize the text-to-voice functions. Because the response we get from the GPT is in text format, and we need to translate the text to speech. After initializing the text to speech and set the language of it, we can directly call the speak function to speak the text of the LLM response. And now I will introduce some layout explanation of our app. We can see in this picture, the hello is the question from the user, and the speak is the text-to-speech button, which can translate the response text to the human voice. And the hello is nice to meet you is a response from the LLM. And in the bottom, in the left button is used for user speaks. The user can click on it, and then you can say something, and then it will be translated to the text in this query edit part. And after the translated, the user can also modify some sentence in this query part. And this is the send button. User can send the query to the model, and you can get the response.
Okay, so that finishes our PowerPoint presentation, and I will play some videos for the demo. Okay, and the videos are here. You can see we use speech as input. So, what's the difference between a dog and a cat? And now this message will be sent to the GPT server, and we can wait for the results. It will usually take some time to process the result. Yes, we can just drag to see if the, okay, here. Okay, there we have. We can press the speech button so that it can read the text for you.
Dogs and cats are two different species of animals, each with their own unique characteristics and behaviors. Here are some key differences between dogs and cats. 1. Domestication. Dogs were domesticated.
So I will just pause the video here because it's a very long text, and we can show how it performs on the local llama server. Okay, so this is our second demo because we changed from the GPT server to a local server, like a llama that is deployed on my lab server. Okay, so you can see that the response is different. Previously, it's a response from GPT, now it's response from LLM. I can ask it a very simple question like, are you GPT or not? And then I press the send button, same logic, and we wait for the result. Okay, you can see that it's much faster. Speak.
I'm Llama, an AI assistant developed by Meta AI that can understand and respond to human input in a.
Okay, I'll just pause the videos here, and that finishes our video demo. And thanks for watching our presentation. And I want to say that as for the workload distribution, Zillion is responsible for the GPT version, and like most of the work for the user interface, the core functions like that. And I am deploying the large language model on the lab server and modify the GPT version to a LLM version and compare their performance. And thanks. That will end our presentation here.